Hello friends, this is Gunjan Malviya from MTech ID 2K21 batch. In this video, we are going to discuss data science third internal paper. Question 1. Consider a tiny data set where some types of error that could occur. Can you find any problems in this data set? Here, this is the data set in which we have to find out the errors. Let us discuss attribute by attribute some of the problems or errors that have found their way into the data set. The customer ID variable seems to be fine. Attribute of zip. Here we are expecting all of the customers in the database to have the usual 5 numeral US zip code. The customer 1002 is okay. Now customer 1002 has zip code of J2S7K7. Unusual may be an error or toss it out. Not all countries use the same zip code. Actually, this is the zip code of Saint Hyacinthe, Quebec, Canada. So probably represents real data from a real customer. The customer 1003 is okay. For customer 1004, we are unaware of any countries that have 4-digit zip code such as the 6269 indicated here. So this means that the zip code or the newly lined states begin with the numeral 0 unless the zip code field is defined to be character text and which is apparently and what happened here. The zip code is probably 06269, which refers to stores Connecticut. Xender. Attribute contains a missing value for customer 1003. The income field is measuring annual gross income has three potentially anomalies value. Customer 1003 income of 10 million per year, possible especially when considering the customer zip code 90210 Beverly Hills. This means that income is neitherlessly an outlier and extreme data value. Certain statistical and data mining model technique do not function smoothly in the presence of outliers. Poverty is one thing, but it is rare to find an income that is negative and as our poor customer 1004 has. Customer 1004's reported income of minus of a negative of $40,000 lies beyond the field bound for income and therefore must be an error. It is unclear how this error is script in with have perhaps. The most likely explanation being that the negative sign is of a stray data entry error. However, we cannot be sure and should approach this value continuously, cautiously, attempting to communicate with the data manager more frequently. For customer 1005, income of $99,999, perhaps it may in fact be valid. But if all other incomes are rounded to be nearest to 50 codes for another anomalies entries, such as missing value, perhaps was coded in an old database to mean missing. Finally, are we clear as to which unit of measure the income variable is measured in? Database of 10 get merged sometimes without, for example, it is quite that customer 1002 with the Canadian zip code, the age field, has a couple of problems, although all other customers have numerical values for age. Customer 100 age of C probably reflects an earlier customization of the main age into labeled C. Customer 1004's age of 0. Perhaps there is a newborn male living in Stores, Connecticut, who made a transaction of $1,000. The age of this person is probably missing and was coded as 0 to indicate this or some other anomalous condition. The marital status. The marital status still seems fine, right? Maybe not. The problem lies in the meaning behind this symbol. We all think we know that these symbols mean, but sometimes surprised. For example, cold water is a restroom in Montreal and turn on the faucet marked C. Since the C stands for short, which means French for hot. Thus, there is also the problem of ambiguity. In the above table, does the S for customers 1003 1004 stand for single or separated transaction. The transaction amount field seems satisfactory as long as we are confident that we know that what unit of measure is being used and that all records are transcribed in this unit. Next question, question number second. Apply data wrangling process in the following databases. This is the given database we have to apply data wrangling processes. The data wrangling processes. All names are now formatted the same way, first name and last name. We have to remove all the commas, errors, and dash from the name column. We have to write in the format of first name and last name. No other entities there. Next column, phone numbers are also formatted in the same way. Area code, ABC, and the remaining code. We have to remit other commas, hyphens, etc. The dates are also formatted numerically in the format of year, month, and date. States are not abbreviated. The name of the state is always in full form, not abbreviated. The entry for Jackie Agarwal did not have fully formed data. The area code on the phone number is missing and the birth date has no year. So it was discarded from the data set. Now that the resulting data set is clean, readable for development or evaluation. This is the final data set which is obtained after applying data wrangling process. Let's move on to the next question. Question number three. Consider the following database. Apply any three methods for finding out missing values. The given table is this. We have to find with user defined constraint, with mean and mode, with random draws from the distribution of the variables. Firstly, replacing missing field values with random draws from the distribution of the variable. Now replacing the cubic inches of table D second 450 and replacing the brand of fourth ID by Japan. Replacing missing field with user defined constant. Replacing cubic inches of second B element by 0 and replacing brand by missing of fourth column. Replacing missing field values with K means, means or modes. Replacing cubic inches of second by 200.65 and replacing brand by US of fourth. Let's move on to the next question. Question. Classify bank loan application by assigning application to one of the three risk class. Use entropy and information gain approach along with the Gini index. Decision tree using information measures. Training data sample 1 to classify bank loan application by assigning application to one of the three risk class. Given number of example S equals to 10 and number of classes equals to 3. Frequency of A equals to 3. Frequency of B is 3. Frequency of C is 4. Overall information in the given data due to uncertainty of outcome regarding the risk class each person belongs to a given guy I equals to minus 3 by 10 log into 3 by 10 minus 3 by 10 log into 3 by 10 minus 3 by 10 of log 4 by 10 equals to 1.57. Let us consider using each attribute in turn as a candidate to split the example. Taking one by one each attribute. Firstly, we are taking attribute own home. For value y, there are 5 applicants who owns home. They are in classes A equals to 1, B equals to 2, C equals to 2. Value equals to n. When value is equals to n, there are 5 applicants who do not own home. They are in the classes A equals to 2, B is 1, C is equals to 2. I of y is entropy of y equals to S equals to minus of 1 by 5 log 2 and whose value can be calculated after calculate is 1.52 and entropy of in n means no is 1.52. Total information of two subtrees equals to 0.5 I of y plus 0.5 into I of n, which is equals to 1.52. Taking attribute merit, next attribute merit, for value of yes y, there are 5 applicant merit. who are in the classes A equals to 0, B equals to 1, C equals to 4. And for value n, there are 5 applicants who are not married. They are in class A is equals to 3, B equals to 2, C equals to 0. Entropy of Y equals to 0.7222. Entropy of N is equals to 0.971. Total information of two subtrees equals to 0.5 into I of Y, entropy of Y plus 0.5 into entropy of N, which is equals to 0.846. Taking next attribute, which is gender, for Y, the classes contain A equals to 0, B equals to 3, C equals to 0. For value n, there are 7 applicants who are female. They are in class A equals to 3, B equals to 0, C equals to 4. Entropy of Y equals to entropy of Y for gender equals to 0. Entropy of n equals to 0.983. Total information of 2 sub 3 equals to 0.69. Next attribute is employed. For value Y, there are there are 8 applicants who are male. They are in class 3, A equals to 3, B equals to 1, C equals to 4. And for value n, there are 2 applicants who are female. They are in class A equals to 2, A equals to 0, B equals to 2, C equals to 0. Entropy of Y equals to 1.41, entropy of N equals to 0. Total information of two subtrees information gain entropy is equals to 1.12. For attribute credit rating, for value of A, there are 5 applications that are rating A with which they are within the classes following classes A equals to 2, B equals to 1, C equals to 2, value equals to n. There are 5 applicants who have rating B. They are in classes A equals to 1, B equals to 2, C equals to 2. And entropy of Y for credit rating is 1.52. Entropy of N for credit rating is 1.52. Total entropy, final entropy for credit rating is 1.52. Potential split attribute, gender. Now we can reduce the data by removing the attribute gender and removing the class B, since all B class have gender male. Now we can reduce the data of by removing the attribute gender and removing the class B. Since all the class have gender male, let us now consider each attribute in turn as a candidate to split the sample. Who owns home or married? For Y, for attribute owns home, for value Y, there are 3 applicants who owns the home. They are in classes A equals to 1, C equals to 2. For N, value of N, there are 4 applicants who do not own home. They are in classes A equals to 2, B equals to 2. Entropy of Y equals to 0.92. Entropy of N equals to 1.00. For next attribute married, for value of Y, there are 4 applicants who are married. They are in class A equals to 0, C equals to 4, value equals to N. There are 5 applicants who are not married. They are in classes A equals to 3 or C equals to 0. Entropy of Y is equals to 0.0. Entropy of N equals to 0.0. There is no need to consider other attribute now because no other attribute can be better. The split attribute merit will be used to split attribute. The rule: if gender equals to male, then class B. Else, if merit equals to yes, then class C. Else class C. Now using it, using finding the with Gini index method. Given number of example S equals to 10, number of classes equals to 3, frequency of class A equals to 3, frequency of class B equals to 3, frequency of class C equals to 3, and the total Gini index for the attribute who owns home is 0.64. The attribute whole attribute for the attribute for the married Gini index is 0.40. For attribute gender, the Gini index is 0.358, and for gender employed, sorry, attribute employed, the Gini index of two subtrees is 0.7475, and for the in the last for attribute credit rating, the Gini index is 0.64. if the rule. If the gender equals to male, then class B, else if married equals to yes, then class C, else class C. Thank you.